Okay, so what you want to have in front of you is your domain and range worksheet. I'm going to first start with the notation that we've already learned, and then I'll show you the new way to notate domain and range. The notation that I taught you in class, it actually has a name, and what it's referred to as is set builder. So it's called set builder notation. How we set it up, so just as a review, let's set up the domain and range. So remember you have your fancy bracket. X is such that, put your X in the middle and set up your inequality signs, comma XER. End with your bracket. Set up your range the exact same way, except that range is your Y coordinates. So Y is such that, Y in the middle with your inequality signs, comma YER. When you have a biggest and smallest X or Y value, and your X or Y is in the middle, you never flip these signs. Some students on their quizzes, you were flipping these signs. You would never flip them. What you need to do now for your domain is find your biggest and your smallest X value. So biggest goes on the right, smallest goes on the left. So for this graph here, biggest and smallest is what I will need. Sean, what did you get the biggest X value is? Yes. So for now, I'm just going to write, I'll just write 3. Smallest X value, Jasmine, what do you have? -6. Then you say to yourself, do I have to erase any equal to signs? And the sign that you would erase is this one right here. It is not going to be equal to 3 because you have an open circle. So I would go over here and I would erase that. Do the same for your range. Find your biggest and your smallest Y value. And remember you're drawing horizontal lines to look where it cuts the Y axis. So your biggest Y value should be 5. Your smallest Y value is -4. And -4 is the one that you would erase. So it would be, you'd erase the equal to, because there's an open dot down there at -4. Remember how you read this. X is such that X is less than 3, greater than or equal to -6. And then X belongs to the element of the real numbers. Okay, here's how you do interval notation. You only need 2 numbers, a comma, and brackets. So what you're going to do is, remember you always have the smallest on the left and the biggest on the right. So I'm just going to write that to remind you. So for domain, your smallest value is -6. Your biggest value is 3. What you would then do is you have to figure out, are you going to use rounded brackets or square brackets? You will use square brackets if it is equal to. So for example, next to the -6, sorry, it was X is less than or equal to. So the -6 would get a square bracket. And the 3, because it's not equal to, you have to put the rounded bracket. So rounded bracket is when it's not equal to, square bracket is when it's equal to. So watch how fast it'll be when you sort of get the hang of it. That's your smallest, comma, that's your biggest. And then you say which one, the 5, it is equal to 5. So that guy gets a square bracket. And this guy would get the rounded bracket because it is not equal to -4. This is called interval notation. So what I want to do for this question is don't even do set builder. You know how to do set builder. See if you could do interval. So find the smallest, comma, biggest X value, and then decide, are you going to put it in rounded or square brackets? So for this circle, Olivia, what is your smallest X value? Sorry? Yep. Nope. You're drawing an up-down line for your, it'd be 1. It'd be right here. That's your smallest x value, comma. Caleb B, what's your biggest x value? 7 is right here. And then what do you guys think? Do you want it in rounded brackets or square brackets? Square brackets, right? Because square brackets mean it's equal to. Okay, range. Do the exact same thing. Find your smallest and your biggest y value. So draw your line going a horizontal line cutting through the y-axis. Xavier, what are you getting as your smallest y value? -3. Caleb H, do you have the biggest y value? Yep, 3. So -3, comma 3. Square brackets for each of these. Okay, flip your page. Do these ones. Do um, this one and this one I want you to do. So because you're not having like x's such that, what you have to start with is you do have to tell me that you're doing the domain. So you just write like capital D colon, and then when you're doing the range, just have your capital R colon, and then you could set up your brackets. Okay, Ainsley, can you read me the domain, but read it as follows? Like tell me square around bracket, number, comma, number, square around bracket. Yep, perfect. And that's exactly what it should be. Smallest x value is -3, the biggest is 1. For the range, oh, this will be interesting. So I'll do the range with you. Uh, Biggest is 0. Smallest is -4. We know that the -4 is for sure going to have a square bracket. What do you think about about the 0? Because this is a 0, right? As is this open one. Raise your hand if you think you know. I want to see how many people think they would know. This one would not be equal to, this one is equal to. So Tristan, which one would you choose? Equal to. Yep, this one would be slightly less than 0, but if this one's touching 0, it's going to get a square bracket. Okay, Tristan, can you actually read me the domain for that second graph? Yes. Did you have a comma in between? Okay. The range now. Juan, could you read me the range? Do you have the range of this one? Square bracket. Nope. Smallest goes on the left. Yep. The smallest y value is 0, comma. What's the biggest y value? It's what you first said, 2. Yeah, so the biggest y value would be 2. Would you put a square or a round bracket? This would be square. Everybody's good with that? Okay, let's look at this one. Let's set up our domain and range. For the domain, if I exaggerate this and it just keeps going forever, what is the biggest x value that I'm going to write? Infinity. What's the smallest x value? -infinity. You can write infinities in interval notation. Smallest goes on the left, biggest goes on the right. Infinity always gets a rounded bracket. So never put infinity in a square bracket. For the range, for this one, if I said, what is your smallest y value? It would be right here at 0. Square bracket because it's equal to 0. If I said, what is your biggest y value? It is going up to infinity. So it would be square bracket 0 comma infinity, rounded bracket because it's infinity. Okay, do domain and range of this one. Raise your hand if you want to read me the domain. Who's got the domain done? That would read it. Okay, Ainsley, what would you say for the domain? Yeah, square bracket -1, comma 3, and that guy gets a rounded bracket. Anybody have the range done? What's the biggest and smallest y values? Is what that's asking. Angel, you want to try that one? Perfect. So the range is from -5 up to 4. Okay, flip over your sheet of paper. Um, you don't have this one, but I want to talk about this one for a second. So just to quickly illustrate this, can you please just draw yourself a Cartesian plane? The graph is going through -3. So just illustrate that. Everybody would get the interval notation, okay? I want to remind you a few things for set builder notation. So set builder notation, start with your bracket. X is such that. If I said, what is the biggest x value? Remember, this graph continues forever up and to the right. So the biggest x value would be infinity. The smallest x value would be negative infinity. Do you remember how to write that? XER. So if you have from negative infinity to infinity, in set builder notation, it's going to be XER. So you'll see that in your practice test. For the range, we'll set that. So y is such that if -3 is your smallest y, so it's going from -3 up to infinity. Remember, for this, you use that -3 and you say either y is greater than or equal to -3 or y is less than or equal to -3. If this is -3 and my graph is above -3, which one would you choose? The greater than or the less than? The greater than. So y is greater than or equal to -3, comma, YER. The reason why I'm showing this is because on your quiz, a lot of you wrote this. -3 is less than or equal to y. Now, this is a true statement. However, I will not mark that correct. You always, when we read the domain, this domain, we read from left to right. So you always have to have either your y or your x here. Okay? So even though this is true, it wouldn't be correct in your set builder notation. Always start with your y, then your sign, then your number. Okay? Um, this will get a lot of you on the test. Yes. Say that one more time. You're not allowed to flip the sign only when x is in the middle or y is in the middle. So this one, this had a smallest and a biggest. So we'll never flip these signs. But if you only have one number, so this one only had one number, it had 0. This range would be y is such that y is greater than or equal to 0. That's what this range would be, comma yer. So again, when you only have one number, you put your variable first, then your inequality. So don't write on your test 0 is less than or equal to y. Okay? As a department, we decided like we will not mark that as correct. Okay, what I want you to do now is you have another handout and it's your practice exam. So take out your practice exam. I'm going to get you to omit some questions. So you'll write at the top of the page what I want you to omit. Don't scratch these questions out after, right? So just save the questions. It's 25 to 28. So you don't have to do those. 25 to 28. On the Google Classroom, I have the complete work solutions done for you. So here is sort of like all of my work done. I highly recommend when you are going through this exam, this practice exam, you have this open because I've got step by step for most of these problems how to solve it. And you would want to look at that, right? I've got like dependent, independent variables written. I wrote things in the correct notation. So it's just, this will be a good resource for you. Okay, I want to start, I'm going to do a couple with you. So what this first one is, it gives you different domain and ranges, and you're matching. So we're going to match, we're going to figure out what's the domain and range of this, 3x squared minus 4. So I want you to take your calculators out, and let's put this in your calculator. So we're going to graph this, and then we'll figure out what the domain and range is. So 3x, make sure you square it, minus 4. Zoom 6, because I don't know if you've changed your window, so just go back to your 10 by 10 window. So this is what the graph looks like. It's going to go forever up and out. To figure out this y-intercept, remember you could do two things. You could either look at your table when x is 0, y is negative 4, or you could second function trace a value when x is 0. Ainsley question. Okay, so let's just do a quick sketch of this graph. Go down to negative 4. Okay, if I said do the domain of this graph, what's the domain of this graph? Maria, do you know what it would be? What's the biggest and smallest x values? What's that? Infinity. So this, remember, goes up and out forever, up and out forever. So the biggest and smallest x values would be, if it was an interval, either negative infinity to infinity, or the domain in set builder would be x is such that x belongs to the set of real numbers. Okay, the range. The answer is going to be in set builder, so this one we'll do in set builder. Y is such that this y, if I said what's the maximum y value, you should say infinity. What's the minimum y value? This guy right here at negative 4. Is your graph greater than negative 4 or is it less than negative 4? Greater. Y is greater than or equal to negative 4, comma, yer. So now you need to look at the answers A, B, C, D, or E, and you need to match it. So what would that match with? Which one has domain of XER and range of y is greater than or equal to -4? C. Yeah, so that matches with C. I would skip this one, okay, skip this one, and then do this one. So see if you could quickly do this one. This one is going to be an interval, the answer. So you can check your answer against mine. Range, I'm getting the smallest is -5 and the biggest y value to be 4. And what would that match with? That would be A. Okay, we're going to type this one in our calculator. If you have a fraction, you enter it in a bracket. So y is equal to, I'm going to put that 1/2 in a bracket. The x will be on the outside of the bracket because it's a half times x plus 6. So let's see what this graph looks like. In a bracket, 1 divided by 2, 1/2 x plus 6. Okay, based on this, let's get the y-intercept. So second function table, when x is 0, y is 6. You don't need it though for this. Because your domain and range, hopefully you know what it is. Looking at this graph. So what that would be if I put it on a Cartesian plane, it would be this. And this value was 6. This one, I believe the answer is in interval. No, it's in set builder. Domain and range, they'd both be XER and YER. You're going to try to figure out this roller coaster one. Like you're going to see if you could sort of do a sketch for that. But then when you're done, look at my picture, okay? And see if it sort of makes sense. That's how I want you to do that question. Okay, so we reviewed that. Let's now go to 23. So we haven't done 23 at all, but you'd be expected to know this. Yes. Oh, did I not write it? Yes, the answer for 4 is B. That would be correct. Okay, so the question is, which of the following represents a linear relation? So all of our graphs have been linear, right? They've been straight lines. And what it's basically asking is, if you plotted these points and connected the dots, would it be a straight line? Here's how you figure it out. So you see how this x value is a 2, right? And then this guy is a 3. We're missing something here. And then it goes 5, 6. What's the x value that's missing here? What would it be? 4. Yeah, so let's put the 4 in here. What's happening is you have to figure out what's happening to each x. If you go from 2 to 3, you're adding 1. Go from 3 to 4, you're adding 1. 4 to 5, you're adding 1. And 5 to 6, you're adding 1. Okay, let's see what's happening to our y values. You are going from 5 to 8. What are we adding here? 3. Just check this one. Make sure it's 3. It is. So what would my missing point be? 11. How you tell if these points would connect into a straight line is you have to have a constant change. So what that means is all the x's have to go up by the same number, and same with the y's. This, if you plotted it, would be a linear relation. It would be a straight line because all my x's go up by a constant value of +1, all my y's go up by a constant value of +3. Check this one. So remember I was going my x's from this x to this x to this x. Now it's just giving it to you in a table. So what do you add from 1 to get to 2? What do you add from 2 to get to 3? And what do you add from 3 to get to 4? What would all of those be? +1. So far, that's constant, right? Now we have to say, what do you add to -4 to get to -3? So sometimes students have a hard time visualizing this, but on your number line, if I said -4, it's right here. If you are here, what do you have to add to get to here? +1. Yep. And if you're at -3 and you need to get to here, +1. And this guy would be +1. Because it's a constant change, the x's go up by the same value, the y's go up by the same value. If you graphed this, it would be linear. So the question is, which of the following represents a linear relation? So far A, B. Let's actually just look at D. What do you guys think of D? Is this a linear relation? No, it is not a straight line. Linear relations are straight lines. It cannot be D. How would you figure out C? What would you do? Graph it, right? So go to your calculator. Y is equal to 2x squared minus 3. Is that guy linear? No. So it's not that one. Just you guys to let you know, all of the, this is a degree of 2. So from polynomials, that's a degree of 2. And all linear graphs, so maybe you want to write this down, all linear graphs or functions will be a degree of 1. So for example, if you punch in on your calculator 3x plus 5, this is a first degree polynomial. It would be a straight line. Okay. Any degree 1, yes. If it's a degree 1, a first degree polynomial, they will be linear. Let's look at this one. See if you could figure it out. The relation between x and y is linear. That means it's a constant change. Which ordered pairs complete the table of values? If you are at 7 and you need to get to 4, what are you doing? You're going down by 3, which is subtracting 3. 4 to get to 1, you are subtracting 3. 4 minus 1, or sorry, 4 minus 3 is 1. 1 minus 3 is -2. So -2 minus 3 will give you your x value. In order to figure out the y's, what's happening for the y's, so again, sometimes it helps for a number line. Here's 0. We start at -4, and you need to get to -7. So if you're here, -4, you're going 1, 2, 3 to the left. You're subtracting 3. If you go to the right, you're adding 3. So this would be -3. This again, -7 to -10 is -3, -3, and this as well, -3. So it would be -13, -3, and what answer would you get? That would give you -16. This guy would give you -5. Which ordered pair would it be? Sorry? It'd be A. Yeah. That's your X, that's your Y. And here's the last thing you just need to add to your test. You will be provided in this chapter, will always give you the equation. So written response number 1, it is missing the equation. So at the top of the page, could you write this? Sorry, it says written response number 1. It's question 31 in your package. The equation is h of t is equal to 2500 minus 20t. This is what you're punching in on your calculator. And then you could get your graph.